Hey guys, I'm Jungwoo,
And I'm Josh.
and today we're going to be solving solutions problem number 8.
Alright, so our problem today is calculating the molar mass by boiling point elevation. A solution was prepared by dissolving 18 grams of glucose in 150 grams of water. The resulting solution was found to have a boiling point of 100.34 degrees Celsius. Calculate the molar mass of glucose. Glucose is a molecular solid that is present as individual molecules in solution.
So basically this problem allows us to calculate the molar mass, as mentioned earlier by Josh, of a solute based on a variety of measured factors. Basically what this problem helps us learn is not only how to solve this specific problem, but also how to manipulate given chemical equations to determine a certain value.
So pretty much there's this one formula that we'll be using to solve this problem, and that is delta TB equals KB times M times I. And so pretty much delta TB equals our change in temperature, KB equals our molar boiling point elevation constant, which is 0.51 Celsius kilograms per mole for water, and then M equals molality, which is mole solute over kilogram solvent. And if we haven't gone over this before, moles are gram substance over divided by the molar mass. Solute is a substance being dissolved, and our solvent is the liquid that the solute is being immersed in. So it's pretty much dissociating inside the water. Our final number is the Van 't Hoff factor, or the number of ions when the solute is ionized.
So we're given the final temperature, which is TF equals 100.34 degrees Celsius,
In our problem.
and we have the given, which is 100 degrees Celsius. And if we want the difference in temperature, we take the final temperature and subtract it from the initial to get 100.34 degrees Celsius minus 100.00 degrees Celsius to get 0.34 degrees Celsius.
Very good, Jungwoo.
So the change in boiling point elevation, delta TB, is equal to KB times molality times I. And what we can rewrite that as is KB times moles solute divided by kilograms of the solvent times I. And based on the definitions we gave earlier, we know that moles solute is equal to the mass of the substance present divided by the molar mass of the substance. Let me stop it. So now what we have is the molar mass here, which is what we are asked to find. So we want to rewrite this as KB times mass divided by molar mass divided by kilograms of solvent times I equals the change in boiling point elevation. So what we can do now is manipulate the equation and do some algebra to get this equation, which is molar mass is equal to the KB times mass divided by kilograms of the solvent times I times 1 over 0.34, which is the temperature given. Now that we've plugged in the difference in boiling point elevation, which is 0.34 here, we can plug in everything else that we know. Since we're solving for molar mass, we can set molar mass equal to KB, which we know is 0.51, times the mass, which is 18.00 grams, divided by the kilograms of the solvent, which is 0.150 liters, multiplied by I, which is 1, and multiply that by 1, divided by 0.34. And the reason why the von Hoff factor is 1 is because glucose does not ionize in the solution. So the number of ions is equal to the number of molecules because there is no ionization.
And remember that this is 180 grams per mole. That is 100 grams, yeah.
So we were able to manipulate an equation and plug in the given data to calculate the desired value of the molar mass.
I hope this presentation has taught you another method of manipulating equations. Thank you very much.